We're moving along with our talks, and it's a great pleasure to have people who actually really do things as opposed to just write papers here. And so Ted Miller is one of those. I've known Ted for a few years. We serve together on an advisory council, strategic advisory council for the Idaho National Lab, and they have a big opportunity to develop batteries, test them, and things like that. So Ted's expertise in the area of electric vehicles and hybrids has been very informative and has helped them a lot. But I guess he started out as a Hoosier, he tells me right now, at the Indiana University, got his degrees in chemistry. So you'll be seeing many others that came up in those routes, Frank DeSalvo being one who you'll meet with later on. But it's interesting to see a way a company organizes itself around this sort of growing interest in electric and hybrid vehicles. And a lot of things are going to be happening in the future, and Ted's been anticipating that. So he's got a big team of people that work for him, and I think they're interested from my conversations with him and others. Professor Hanrath was with us there this morning, that every aspect of how you put together this system, whether it's the creation of the battery itself and the storage mechanism, or how eventually you have to recover them and get some value out of them at the end of life of a vehicle, and how it would perform in this very challenging area of having competitive, affordable vehicles these days that are electric and take advantage of, let's say, lower emission capability that you can do with electric vehicles. So we're really glad to have you here. I'm sure that there'll be opportunity afterwards if you want to come to the lunch, which will be on the third floor of Upson. We'll say something about that at the end. I think it's in 331, we think. That's the right room. It's in the corner of Upson on the northeast corner. Thanks, Ted.
All right. Thanks, Ted.
So I can even, if you want me to turn the lights down a little bit so the slide, so I can do that, but it's up to you.
Okay. All right. Well, my thanks to Professor Tester. I've enjoyed collaborating with him on our advisory council. Yeah, hopefully that looks okay. It looks a little stretched. And I appreciate the invitation to be with you today. So I'm going to talk a bit about, and this might be getting cut up. I might. Oh, is that? But I'll speak up. Yeah, thank you. And I don't know if this is quite the right resolution, but hopefully everything shows up. So I want to talk specifically about these enablers and barriers to electrification, vehicle electrification adoption. But as I had this talk prepared, and I thought, here I get a great opportunity to talk with faculty and students at Cornell. So I want to start with a little bit of a preamble. I'm ever recruiting talented people, so that's part of my motivation. But also, collaboration and research is important too. So I want to talk a little bit just at the start about innovation, sort of past, present, and future at Ford. Of course, our founder, Henry Ford, was kind of an innovator in developing this moving assembly line and picking up on cues from actually the meatpacking industry in the day. Cars were sort of built station by station, and he realized that there was a more efficient way. So really, innovation, we say, is sort of in our DNA, even starting with the founding of the company. Obviously, we're involved. We're sort of what's called a full line manufacturer. So we do everything from cars, performance vehicles, the GT probably most notably, but all the way up through trucks. And you see kind of the image down below. We're actually sorry, this is getting cut off a little bit off your screen. But in any case, we are actually the #1 producer of commercial vehicles as well. So not quite the big tractor trailer, but everything up through that. So yeah, maybe it's just a matter of the screen coming down.
Projector that needs a little bit of.
Oh, there we go. Thank you. Great. All right. And so one of the, sort of part of our viewpoint is we need to look at society as a whole and sort of what are the key things that are happening and how does that influence what we do in our business. So clearly we're seeing a lot of growth in urbanization, notably outside of the U.S., perhaps more than in the U.S., but even in the U.S. Actually, we're starting to see, even in a place like Detroit, kind of a repopulation of the city and an interest in city centers, and especially, I think, younger people are really migrating and drawn to cities, better opportunities, and I think that's even more true outside of the U.S. growing middle class growth. We see that obviously in places like China, and it's emerging in India as well. So really large societies where this is occurring. That's changing some of the factors in our business. Air quality is a key issue, I think, globally. There are some areas where it's obviously an acute issue, and I'll talk a little bit more about that. And then just, kind of changing customer attitudes. And some of this is change in attitude, and we're also seeing some things like, some deferring, especially among maybe younger people like yourselves, millennials doing things maybe at a different pace or on a different schedule. And so that's changing sort of some interests and some patterns. And then we look a lot at, we have a so-called technology advisory board or technical advisory board within Ford. So that is comprised principally of our Henry Ford Technical Fellows. So we have a few people at the company that are recognized as technical fellows, and a few of us are also advisors to them, but really looking at key technology trends. So whether or not it has a direct impact on our business is TBD, but what are the major trends? And so I won't go through all of these, but clearly a lot of these are influencing what we're doing, and a lot of the technology that may be developed elsewhere, how do we employ that? How do we take advantage of that in the industry and make better products, obviously? Okay, and I'll talk a little bit about research and advanced engineering. So that's the area that I'm in at Ford. This just gives you an idea, a few snapshots. The one on the far right is our primary research center in Dearborn, so close to Detroit. Some of our folks there. The image on just to the left of that is in Aachen, so our other main research center is in Germany, near the university there. And then our Palo Alto campus, so we're just off the Stanford campus in Palo Alto, so that's a shot of facility there. We just actually moved into new facilities in Palo Alto. We have room there for about 500 people. We have about 250 people in Palo Alto now. That'll grow out. And a lot of work is being done in mobility, vehicle automation, et cetera. But this just gives you an idea. We have about a third of our folks are PhDs, mostly advanced degrees, and then bachelor's degrees as well. A lot of diversity. We have people from 55 countries in the lab, some 3 major geographical regions, so where we're located today. We also have centers, and I'll talk a little bit about what we have in China. And this just gives you an idea of the portfolio. So I'm involved principally in powertrain research under electrification, and we also classify fuel cells in that area. But we have a really large group of people involved in autonomous vehicles and controls. Actually, Ford just very recently developed an LLC around vehicle automation. You may know that we acquired Argo AI. That was out of Pittsburgh. Remind me of the school there, but yeah, Carnegie Mellon. I should have known. Yeah, it's not an insignificant school, but a lot of folks were. The genesis of this was out of Carnegie Mellon, so we acquired a company there to do some of the virtual driving system itself, as well as Ford work there. But that's now been consolidated into a large and growing entity, actually, with some. We'll have some private investment there, and then we have a large area called Vehicle Enterprise and Sciences. So imagine material science, but it really covers a broad spectrum, but even things like connectivity, cybersecurity, mobility, et cetera. So these are kind of these are the directorates that we're organized into today. And actually, I've been in multiple directorates, so I don't know if anybody quite knew where energy storage fits. I always felt it fit in powertrain, so finally I sort of migrated the group over to powertrain, because to me it makes the most sense. And I'll just talk a little bit about it. I mean, I think what's most notable, our work in materials, probably the most obvious example is our work to have a aluminum bodied F-150. We have high-strength steel frame, all aluminum body. That was a huge lift. Actually, it started in research about a decade ago, so that's the time frame to get things like this done. Over 5 years ago, 5 years before production, we had to engage key suppliers, so in this case Alcoa and Novelis, to actually put in enough smelting capacity. We make 800,000 of these vehicles a year, so we needed a lot more aluminum capacity of the particular grade that we had defined. But this saved 600 pounds in a vehicle, so it's really significant. It was funny. I'd just give you a short story. It was interesting. I was driving some vehicles on our local test track, and early days of prototype of the new F-150, we were comparing it to the existing model. And I was talking to the chief engineer, and I said, "Oh, this is great. Of course, I'm all about fuel economy and lower CO2 footprint." And I said, "Oh, this is great." I said, "This is really going to help our fuel economy." He said, "I can't sell fuel economy." He said, 600 pounds that we say is in this car, it's payload. and the customer will absolutely pay me for payload. I can't sell a few miles per gallon for 600-pound weight savings. He said, but we're going to have by far the best-in-class payload capacity of any any half-ton pickup truck. So that was sellable. It's interesting. Now it changes the vehicle dynamics are better. There's lots of improvements that come from this aluminum, but it was just interesting. It kind of brought me down to earth, like, oh yeah, this is how we make our money. I need to understand this better. Okay, and then obviously we do a lot of work in carbon fiber, most notably, of course, the GT. It's a carbon fiber, really carbon fiber intensive vehicle design. Obviously a very specialized car at a very high price point, a fantastic vehicle, but where we're taking this to a more practical level, on the right you have a carbon fiber wheel. That wheel went into our GT350, so a Mustang, so that is a production vehicle. We've got collaboration with Dow AXA, for example, and we're working with Oak Ridge National Lab on really low-cost methods to produce carbon fiber for vehicle applications, a much broader scale. Again, when we think about doing this, and I talked earlier today about this, when we wanted to do an aluminum-intensive vehicle, frankly, doing a niche vehicle didn't make any sense for us. We needed to do it at scale. There's nothing bigger scale than the F-150, so that was the right level to bring this out. And one of the things that we've done is, and this was again a research project at its beginning, was EcoBoost, so direct injected turbocharged engines. Now it proliferates. There was a lot of skepticism, I think, when we talked about putting a 6-cylinder engine as our flagship engine, turbocharged engine, F-150. Now by far it's the most popular choice. It's got the best torque, the best performance characteristics, best fuel economy. So this is across all classes. We've got a 1-liter engine that's just incredibly capable and great for fuel economy. So this has been a real win for the company, this so-called, what we call EcoBoost. We branded it as EcoBoost technology. And then a lot of work on natural materials. Ford's really leading, I think, in this way, and probably, as many things, we do it kind of quietly, but all of our foam in our seats is soy foam at this point. All the products we build are based on soy foam, so, biodegradable materials. One of the things shown here is bamboo fiber, so we're using bamboo and especially using different materials in plastics for structural integrity improvements. And so we've even looked at currency. As you can imagine, there's a lot of currency coming out of circulation anytime. That's ground, and we look at using that currency. We're actually using it in some applications. So filler, but just basically reusing a filler. Our currency is kind of unique. It's actually linen, and it's a blend of different materials. And so anyway, it has some unique properties, and so we're able to reuse it. So we're always looking for, we've used some Coke bottles, so we've used some of the bottles and made seat fabrics and did a collaboration with Coke. But it's just all about, if you think about automotive scale manufacturing, you think of any other waste stream, is there any opportunity to sort of reuse those things? Okay, autonomous vehicles. I'm not going to spend a lot of time on this now, and I'd love to at some point. I've mentioned before that our first introduction is planned for 2021, so pretty soon for an automated vehicle. Our target for our vehicles is level 4, so very high automation, but a geo-fenced area. We're looking for this TaaS, or transportation as a service, for people and packages. That's our target. So think about Lyft or Uber being interested in these kind of vehicles as a shared platform. There is more expense associated with this kind of processing and sensor capability and this automation. So we envision that the first experience people may have may be in a shared mobility experience, and then this may obviously proliferate further. But this is our first effort in this. It's an electrified vehicle, and I've mentioned earlier today that all automated vehicles are electrified vehicles. If you just look at the processing load alone, you need an electrified vehicle to manage it. Okay, and so so where we're at now is this level 4 automated vehicle standalone, and really doesn't require information from the outside world. So that's one challenge. If we had fully connected vehicles, we could simplify designs, but today we have to know everything. But going sort of further, it's when we start to have vehicle-to-vehicle communication or vehicle-to-infrastructure communication through this dedicated short-range communication protocol. So it's nice that that's been defined, but obviously in that case we can start to be more intelligent about what traffic lights are going to do, smarter paths, et cetera, et cetera. And then finally, this 5G is, you can see what's coming in the future. And so this is sort of what we see coming in vehicle automation, things that will influence our choices in automation. Okay, and one thing I'll mention here is that along these lines, we've had a lot of involvement in a couple of test tracks, automated test tracks, one at the University of Michigan called M-City and another nearby. But then also AI is going to be big in this as well, and so Ford actually is funding the building of a robotics building, and that's underway. I think it'll open in next year, 2019. So at the University of Michigan, we'll have a Ford Motor Company robotics building. So that's a big investment. We'll have quite a few people there in collaboration, directly sitting with effectively faculty and students as well. Okay, and now I'll provide a little bit of perspective, maybe, with respect to demands on new vehicle powertrain architecture. And this is just a view of primary energy consumption. I think this group is probably well aware of this. Yeah, so I think you're well aware of this. Obviously, we in the transportation sector are big users of petroleum, obviously, but if you look at the total energy input to the system, transportation is just a share of that. Some natural gas, as you know, and then some renewable energy, et cetera. But principally, this is where transportation lies, and that's all types of transportation. That's commercial, fleet, as well as retail. And then from a regulatory standpoint, and I'll mention this and look at it a couple different ways, but this is light truck per gallon normalized to CAFE. So this is what you're kind of used to seeing, either miles per gallon or kilometers per liter, as is typically known. So all the sort of solid lines are what is the historic average, and then what's going to happen between now and 2030 from a regulatory standpoint, where we have to get to. Another way to look at that, of course, and I'll cover this a bit later, is going to be from a CO2 and emission target. And here you see kind of a convergence. I'll show you a little bit later more detail. But the point is, these are obviously key influencers of what we need to do. We're a really well-regulated industry, or a highly regulated industry, I should say. So, obviously this has an influence. Frankly speaking, though, I would just say that this doesn't matter much if your cars can't sell. We have to have appeal to customers. We have to have price points people can afford, because all this is incidental. This obviously is the minimum, but what do people want? What will they drive? What do they want to pay for? And where are you providing value is really what's important. Okay, but there's things that certainly are affecting places like London, like Mexico City, and really large populations or really congested areas. But access to low emission zones, sometimes zero emission zones, and this is certainly coming in the future, where you will not drive a car into a city center if it isn't zero emission, or a truck. So this is influencing what we may do in commercial vehicles as well. And incentives for hybrids, electric, greenhouse, or CNG, compressed natural gas-based vehicles. Those incentives exist. I'm going to talk a little bit more about that later. And then lower vehicle maintenance costs is another driver. There's really not much to do on a pure electric vehicle. We don't change oil. Brakes are mostly braking as regenerative primarily. So you need to replace tires, but there's not much more. Now, frankly, I'll tell you, I was talking with a group a couple weeks ago, and that's a real conundrum for our dealers. They make a lot of their business is doing service on vehicles. So, if somebody was complaining to me saying, "Oh, I went to a dealer and I was interested in your vehicle and they didn't know much about it," I said, "Well, it's difficult for them. They're not sure where this fits. They're independent business owners, and they make their money doing service on vehicles. And so, this is a kind of a brave new world for them. Usually, when I've heard that complaint, I say, find a young person, because they're going to be interested in this. But sometimes you get to a dealership, this, because you have to find the person that knows about this technology. First of all, they don't move that much product. But the other thing is, it's just, what pays the bills. The F-150 pays the bills at a Ford dealership. That's a fact.
That could change, though.
That will change. Right. Well, it could be a different F-150 that pays the bills. Okay, and so I won't belabor this too much, but there are obviously different choices for powertrain architectures for electrified vehicles. We've certainly looked at all these. We've invested heavily in our power split. So the center is our power split hybrid design. That's where Ford's really invested heavily, at least for front-wheel drive cars to a certain class. So we would say through like a CD platform, that's the right architecture. For our rear-wheel drive cars, we're using a different architecture, different hybrid architecture. So I'll talk a little bit about what we're bringing out in the future and where those architectures will play. And then this just gives you an idea of what the functionality of all those choices are. Obviously, one of the reasons we've been bullish on full hybrids is it gives you the maximum fuel economy benefit. You also enable all of the features that come with electrification, and then obviously you can extend that further with plug-in hybrids to provide pure electric driving much of the time. Really significant fuel economy benefit, finally to the limit of BEVs. But I think this is understood by this group. And this is kind of what the expectation is if you look, and this is really a pretty short time frame. We're already in 2018, so obviously in 2015 the market was pretty small, and there's a lot of discussion about, well, it's 3 or 4% of the total market for electrified vehicles, principally hybrids, as you can see in 2015. But just within a couple of years, we see that changing. So, zero emission vehicles, and you can read that as BEVs in the near term, are really going to be increasing even in that period of time. A lot of hybrid electric vehicles, and again, those can be plug-in hybrids as well as traditional hybrid vehicles, again, increasing in 2025. We see by 2030, and this is kind of a consensus of a lot of analyses that are out there, that really it's a pretty even split. So we're within about a decade of seeing a real significant diversity in powertrain offerings, and by necessity and by choice.
So those are new?
Yeah, these are new vehicles we're talking.
Yeah, these are new vehicle sales, right? So this would be sort of, if you looked year by year, by 2030, the vehicles selling will be this. The car park will still be, more.
How many are we talking about roughly at 2030?
Yeah, so
Chinese growing quickly.
Yeah, so today the market is roughly 80 million, I think, roughly 80 million vehicles sold globally. By 2030, it's closer to 150 million. So it's huge, and then most of that growth occurs in China. The U.S. market may grow to 20 million. The market in China, I think, is closer to 25 million already. It's by far the largest market, and that market is likely to go to probably 35, 40 million alone. So it's north of 100 million vehicles, far north of 100 million, probably 120 million vehicles. So I mean, that's just the demand for transportation. So where would they all go? That's going to be one good question. So I wanted to give you a little bit of history. I wasn't involved in the 1913 work, but I'm not that old. But this has been around for a while. This is Henry Ford and Thomas Edison working on an electric concept car. Nickel iron batteries were used at that time. People tried through the 80s to make the nickel iron battery work. But so this is obviously not a new technology. Clara Ford, Henry's wife, actually drove an electric vehicle through about the early 1940s. So in '66 we had some work in Europe. So we had this Commuta vehicle, lead acid batteries at that time. We moved in, and actually Ford in the 1960s invented the sodium sulfur battery. So that was done at Ford Research. We finally put that on wheels in mid '80s in this so-called ETX. This is our old, we call it the Aerostar van at one time, a rear-wheel drive minivan, early days minivan. And so we put the sodium sulfur battery into that platform, obviously not for production, but we did that as an experiment, and it's called it the ETX2. By '92, we had taken our European Escort. This was a small kind of delivery vehicle based on our then Escort, and put the sodium sulfur battery. Now that was about 100 vehicles that were distributed nationally here in the US, a few in Europe, again, still trying to use sodium sulfur battery. Sodium sulfur battery, so that you don't know, it's a molten battery, so those batteries operate about 350 degrees C. So it's a challenging battery to make work. I came into the company just about the time that was about at its end game. In fact, they asked me when I came in, what do you think is going to work? And I said, ambient temperature lithium batteries. I said, I know you guys have worked on this for decades, but I don't see how this sodium sulfur battery is going to work in mobile applications. It's worked well. I mean, that technology has been used in stationary applications for quite some time, especially in Japan. It's just really challenging, and there's no other outlet for the battery. There are very few outlets for that kind of a battery. So by by 98, 99, we were basically had a memorandum of agreement with the state of California especially, but we actually sold these vehicles here in New York State, and we've sold vehicles throughout the country, not just in California, but we came out with our electric Ranger. So our Ranger EV, we started with lead acid, went on to nickel metal. This is about the time I got involved in with Ford. I came in '95, so I was involved in these programs. And then finally, in 2004, Professor Tester knows this vehicle well. He had one of our Escape hybrids. Yeah, so this was a great vehicle, and that was using nickel metal hydride batteries at the time. We then went to our Gen 2, our so-called Gen 2, so this was a power split type design. We went to Gen 2, we launched in the Ford Fusion, the Lincoln MKZ, again using nickel metal hydride batteries in the first generation. 2012, across the board, we moved to lithium-ion technology, so that was in hybrids, plug-in hybrids and electric vehicles. Wholesale, we went to lithium-ion technology, and you can see the cars that we're selling today that have those versions of technology. Okay, some people don't know we're the second largest seller of electrified vehicles. We're a top seller of plug-in hybrids, and I'll get into this a little bit later in some more detail about what we're doing between now and the next few years. And then just probably I have a chance tomorrow to cover this in a little more detail. This just gives you an idea of the generations of battery technology, again, an area I'm much more focused on, but you see what we're doing in improving the capability of these from a mass standpoint, power capability especially. This is for hybrid application. We really focused on the power density of these batteries, much smaller, much more compact, easier to package, and much more efficient. And if you're talking about electrification, this gives you an idea of kind of our global footprint. So we have obviously the research team that I'm involved in. On the left side, the second picture, that's our Research and Innovation Center in Dearborn. So a lot of us are there. We have a so-called Team Edison now. We're in downtown Detroit. One thing not pictured here, I should have included, we just bought the Michigan Central Station, so a really large, beautiful train station from about 1918, I believe. It was built by the same architects that built the New York's station, Penn Station, I believe it is. So Grand Central Station. So same architecture, or similar architecture. Ford bought that building. I think we're going to spend $700 million, I believe it is, in renovation. So you could tear it down and start over, but we wanted to keep the history of that building. So we will have about 5,000 people in downtown Detroit. About 2,500 of those will come from our supplier collaborators, and about 2,500 from Ford. There's actually going to be retail. There's going to be living spaces on top of that. So it's kind of a neat space. It's in a Corktown area of Detroit. And then we have, this is an Albert Kahn design building on the lower left. That is where our Electrified Powertrain Engineering Center is located. That's a really historic building for Ford. Really neat history there. It's all been renovated, and that's where our engineering team is located. But we also have our electrified powertrain engineering team in Dunton in the UK, in Merkenisch in Germany, and then I mentioned that in China we have operations, so that's in Nanjing. We have a research center in Nanjing. So that's, in total, that's our footprint in terms of electrification resources, both research and advanced engineering. And this is a bit about Team Edison. I won't get into this in much more detail, but but I have mentioned that, you know, our plans to kind of offer hybrid options on really high volume nameplates. So the F-150 we're going to have a hybrid version of, Mustang, Explorer, Escape, Bronco. Bronco's a vehicle kind of being reintroduced. So you know, in addition, as you said, hybrid options for every new SUV Ford introduces. So good news for Professor Tester. He's been waiting patiently for our new Escape. And then in North America, this just gives you an idea, and this is really some work, especially that our team is sponsoring, so just to give you an idea. I don't have time to go through this in great detail. We do a lot of collaborations. These are some of our collaborators. We collaborate with many universities. We collaborate with national laboratories, et cetera, and have specific projects that, again, I'll cover in a little bit more detail later. In Europe, again, we've done a lot of trials, so a lot of our mobility experiments have happened there. Plug-in hybrid vans have been one of our key focus areas, but with Deutsche Post and DHL in Germany, and in collaboration with a company called Street Scooter, we've worked, and they use our platform for, these are fully battery electric vehicles. And I'll talk a little bit more about Ionity and what we're doing on charge infrastructure, but we started that effort in Europe. And then in China, again, I don't have time to get into all this, but we've got fairly significant plans in China. As you can imagine, we've got the collaboration with our smart mobility team and Zotye. We have an MOU there. That's for a whole range of vehicles, so not just traditional vehicles that Ford produces, but smaller vehicles and more city vehicles that are very popular there. Okay, so now I'll get into the sort of meat of the talk and talk about enablers. I mean, one of the key enablers really is just the fact that we as an industry are investing about $100 billion in this over the next few years. These are announcements that have occurred just since the first of the year. So these are really dramatic investments. We've talked about, and we'll invest $11 billion by 2022 for our 40 new electric electrified vehicles worldwide. Volkswagen is stepped up $40 billion. You see the breakdown there. It's $20 billion in the US, $20 billion in China, $50 billion in Germany by the automaker. So it's unusual to have people, we usually don't brag about the amount of money we're having to spend to develop new products. So this is obviously a unique situation. But what I would say is that what this is telling you is we're always, obviously as an industry, always investing in powertrains. Clearly, this is a dramatic shift in where we're investing in powertrains in the future. So we only have a limited budget to everything we can do. This is a huge investment in electrification. So it gives you an idea where we're headed. And I talked about this a little bit. I'm going to give you a little more detail. I think what's important here is that there's really a convergence in terms of CO2 and fuel economy for vehicles. It's really a global convergence. And this is good news for a company like Ford. We operate throughout the globe. And so for us having dramatically different standards from country to country or even state to state in the US in some cases, that really complicates business. But frankly, as a global manufacturer, we are going to satisfy all of these markets. So clearly we have solutions. But I think the good news is you're getting much less dramatic differences than you'd seen in the past in terms of let's say, regional CO2 regulation. So good convergence here. Obviously, it's a question whether U.S. blinks at this point. It doesn't really matter. We're going to have to deliver to all markets, to China, to Europe. And so, all it may mean is that we may be able to sell different vehicles in the U.S., but our powertrain technology is going to have to be compatible globally. That's no political commentary, just try to stick with the facts. Okay, obviously air quality and climate change concerns, I think these are key motivators. Most of it is obvious. I think we see glaciers receding. That's really worrisome. It's an indicator of what's happening in terms of climate change. So at least at Ford Motor Company, we're not questioning this. Our question is, what do we do and what's our responsibility in this respect? I don't think there's any question about the science. That's my own comment, but I'm aligned with Bill Ford at least. Let's put it that way. And then I think this is interesting. I pulled this out of what came out of Davos. So the summit in the World Economic Forum. This is interesting. If you look over time, and there's a couple different things that they look at. One is what are the risks, and then what's the likelihood. I think what's interesting here, just reading this myself, that it's obviously climate change is a concern, but you're starting to see sort of the effects. These extreme weather events have really risen in terms of concern. Natural disasters, obviously things like cyber attacks, data fraud, we see that. But even, now we're seeing, failure of climate change mitigation and adaptation, or adaptation. So, I think that, it's interesting. These are obviously, kind of political and economic leaders, and I think that you're seeing that this is very much on the radar and becoming a much more pressing issue globally. So I think that's, these are enablers. These are things that help us to move forward with our plans. Okay, and so in terms of incentives, I mean, this is a mixed message. Incentives certainly work. So if you look in very specific places, so you look in a place like Norway or you look at the Netherlands, and we break this down by either PHEVs or pure BEVs, and then what's the market share? So that's what this is telling you. So bars are kind of the incentive, and then what's it doing to market share? And you see that it can definitely work. In some places, again, like Norway, where the incentives are huge, it certainly has changed the market, affects Sweden. But it's really much more mixed in a place like China or really large markets like the United States. While the incentives exist, the movement in the market, and I would just submit that these incentives are nice at the beginning of the market, but no government can afford to pay these incentives for any period of time. That's not a sustainable way forward. You and I as taxpayers don't want to subsidize everything that we do in this respect. So I think that this is a good way to get started, but we as an automaker can't assume these incentives are going to last forever. It's just not realistic. We have to have a business case that is supported independent of a government action. Okay, and this is good news. I mean, the good news is that we've seen a significant reduction in lithium-ion batteries. That's going to be the workhorse for our technology, our electrification technology going forward. Certainly seen prices dropping, so the observed prices here, and this is Bloomberg New Energy Finance that seems to be on the heartbeat of this pretty well, and we've got similar analyses within Ford. And then the projections are not hyper aggressive, but you're in the range of, between say $75, $100 a kilowatt hour, and that's starting to make these vehicles much more affordable. So this is a significant change. This is probably a challenge. I spoke a little bit this morning with others about, sort of the competition between fuel cell vehicles and battery electric vehicles. At least for passenger vehicles and lighter duty vehicles, it's obvious that batteries will be king. And one of the things we see is, improvements in the technology. So this is lithium-ion technology. It got commercially introduced by Sony in 1991. And we've seen a very steady, this is not Moore's Law, so this isn't, quite at that pace, but clearly steady improvements. The one thing that happened between 2005 and 2010, there were actually some issues. That was in the era of some laptop fires, and they had to get a little more conservative in design and et cetera. But in general, you see a very good trend towards improving. This is specific energy or gravimetric energy density. And so, very significant improvements, and that's been essentially continuing. I think the other thing that's a key enabler, one of the reasons we were able to move from nickel monohydride kind of on the left side in our hybrid, we principally were focused on hybrid solutions, but when we wanted to go across the whole spectrum of hybrids, plug-in hybrids, battery electric vehicles, it was obvious that there was much more flexibility in lithium-ion technology. We could take this design and flex it to be much higher power, much higher energy. So that's what this is trying to convey. Is this is one of the things I put together to convince the company that we just needed to move wholesale to this technology for several reasons, but including the fact that it could satisfy all of our application needs. Okay, and then I think there's really been some significant evidence is, obviously, a lot of research has gone into lithium-ion technology. There are other technologies that are certainly being studied. This is the number of publications by year. But you see that there's been tremendous work that's been done in lithium-ion technology. And frankly, even though we adapted the technology in 2012, we were doing that on the shoulders of a lot of research that was done for consumer electronics. One thing that's maybe noteworthy is that the consumer electronics, what's in my laptop, what's in every portable device you have, and every cell phone is just cobalt technology. It's lithium cobalt oxide technology. We never introduced a battery in a car that had lithium cobalt technology. First of all, it's too expensive. It's not thermally stable enough. So one of the things that had to happen during this sort of phase from when the introduction of the commercial technology for portable applications to automotive is we needed much better cathode materials. So we needed different transition metal oxides for cost reasons, for thermal stability, and for lifetime, for durability reasons. So when they was introduced in vehicles, we'd already had a whole new class of cathode technologies. And this just gives you an idea. This is just one example of what LG Chem. So LG Chem is one of our producers for our electric vehicles. We work closely with Panasonic and LG and others. But this is what they're doing. This is kind of their response, which again is good news for us, how they're responding over the period in terms of their investment and the total number of people who are dedicated to this technology. So features enabled by vehicle electrification, obviously fuel economy, flexibility of fuel, of your transportation fuel. This quiet, seamless driving is a key selling point, but we're even thinking more broadly in our whole portfolio, even enhancing performance. So when we talk about the Mustang, it can't just be about fuel economy. It's also got to be giving the customer the performance they expect with the fuel economy they want. But some new technology, so onboard electric generator. When we introduce the F-150, we'll have up to 7 kilowatts of exportable power. So for a contractor, that's really great. They've got now, they don't carry a generator around anymore. They've got a vehicle that provides power generation to an entire job site. So that's a key selling point. In the future, as we start plugging these vehicles in, vehicle-to-home capability is going to be possible. So not just getting energy from the home to charge the vehicle, but then also being able to provide energy back in, especially if you have significant solar capability at home or you want to arbitrage some of your energy usage. And then I've mentioned autonomous vehicles. So autonomous vehicles are electrified vehicles. Okay, I mentioned this a bit about fast charging, but this is the fast charging network that we're doing in cooperation with BMW, Daimler, and Volkswagen. So we'll have up to 300. These stations are already underway. We're going to have 200 of these, I think. Next slide will give you more detail. This is already being built out in Germany and Austria. So it's basically a corridor where we're putting up to 350 kilowatt stations up to 1,000 volts. So very fast charging, almost extreme fast charging by this definition. So this work is underway. I'm sorry, it's 400 stations. That'll be by 2020. This is a project we call Ionity, and you can see some of the details here. We want the intervals to be no more than 120 kilometers. Norway, Germany, Austria. So this is really, we think, going to be one of the enablers, at least for adoption. So reducing a barrier to adoption. Okay, and this talks a little bit about what I mentioned in terms of penetration. This was AVL. AVL is pretty conservative, but this gives their viewpoint again through that same time frame, about 2030. So in the gray, you have kind of the traditional internal combustion. You see, and to your question, Jeff, think it's almost 120 million is the anticipated volume from where we're at today, around 80 million. So this is a growing market, obviously, but in terms of the ICE share, that's certainly going to be dropping, and you see that roughly breaks into about third. So what we have here is ICE on the lower part, hybrids, and then plug-in hybrids when you see the battery, and then pure battery electric or ZEVs, including a small fraction of fuel cell vehicles that they anticipate. And these are just factors that will influence that, as we said, zero emissions, et cetera, zero emission zones, and so the things that will or won't affect that much. Okay. So this is another enabler. I think that we talked about what's coming. The good news is that our suppliers are responding. So basically in green you've got what's already commissioned in terms of battery capacity and where it is geographically. The size of the bubble kind of indicates the capacity at that location. You've heard about a gigafactory. This represents 300 gigafactory is a gigawatt hour. This is 300 gigawatt hours by 2020. So just within 3 years, there's going to be a 170% increase in battery production capacity. The red represents the new capacity, and clearly that growth is principally in China. It will happen elsewhere, but principally in China. The big red dot in the south, the west part of the U.S. is the one gigafactory that Tesla will have. Yeah, exactly. So this is good news. This is an enabler. These are things that are going to allow us to move forward because the investments are happening at our suppliers. Okay, and then another thing that helps, and I won't belabor this much, maybe we'll talk about it a bit more tomorrow, but it's some level of standardization. So this has helped at least to get the market rolling, especially what we have highlighted here is particular cell types. So this VDA is a German industry, automotive industry group, done a nice job of basically taking things that existed and kind of standardizing them without a lot of cumbersome, long-winded committee actions, just basically agreeing as an industry. And so that's helped. I think that's an enabler. And then I mentioned a little bit in a slide about what we're doing, but one of the things that we are really focused on is battery safety, and specifically being able to simulate battery safety. So Ford's undertaken an effort to have the capability at all scales, sort of meso to macro scale, to be able to simulate battery safety response to a range of inputs, especially we consider crush due to a crash, for example. So I sort of think about where we were 40 years ago with vehicle crash. What you did is build a lot of expensive prototypes and you crash the vehicles and you figure out what happened. Nowadays, most of that is in simulation. That's CAE. And we do a minimum number of crashes because we have really good analytical capability. In batteries, we're not there yet. So we want to have the same analytical capability to understand how's the battery going to respond. Essentially with fuel, does the fuel leak or does it not leak? That's your test. In this case, we've got energy that could be stranded, and what's the long-term effect? If you have an impact, what is the final result? So this is work we're doing. This gives you a couple stages. We have kind of an alpha phase where we're looked at up to about cell module level, and then in the beta phase, and with that release, we're moving up to the full vehicle battery system simulation. Okay. I mentioned enablers. I don't know, how's my time doing?
We've got about 3 minutes.
Oh, I don't have much. Okay.
But you are going to be here tomorrow morning.
Yeah, I'll spin through this kind of quickly. So this is interesting. So these are what may be barriers. What you see here is gasoline price and hybrid vehicle sales. These things are obviously very strongly correlated. PEV sales not as much, so plug-in vehicles not as much. The bad news, I would say, is that the average price of gasoline has not really ever changed in this country. So, the price in 1918 was, if you look at the value of $1 today, it was $4 a gallon in 1918. When I started driving, it was over $3.50 a gallon. So the reality is that we're about, so as an influencer, at least in the US, this isn't much of an influencer. This is not going to move people to vehicle electrification. So we can't assume this will help. Obviously, we've had some spikes along the way, but if you look at the lifetime average, it's really, really quite stable. This could be a challenge. It's basically what happens to vehicle range due to battery performance as well as heating. So when we provide heating in an electric vehicle today, it's not very efficiently done. If we compare that to what happens in an internal combustion engine, very little difference. It's actually the density of air at low temperature that actually affects your aerodynamics more than anything else, or the aerodynamic drag. And then this is my last couple slides. I think another challenge is how efficiently we package these batteries. So we look especially from a cell level to the finished battery, how efficiently do we package? Our goal in USABC is at least 2/3 of the value of the cell energy density we preserve at the system level. Very few manufacturers are meeting that today. Ford's included among these, so I've included us. It's one of those. And we're doing better in terms of mass efficiency, and I think actually USABC could be more aggressive in that respect. Fast charging, another one I mentioned. So lithium-ion technology in and of itself is capable of fast charging. On the left, we see what we're doing in the electric vehicle. We have very high power cells that can be charged in 3 minutes. There's a compromise there. There's a cost compromise there. And finally, automotive demand for batteries. Within probably 5 years, we're going to be the #1 consumer of lithium-ion batteries. And so we have to be mindful of that. What is that going to do? Things like lithium demand or cobalt demand, and what's the risk in terms of supply. So these are things that could be inhibitors that we have to watch for. We have to keep reducing our dependence on a specific material. Already batteries drive the demand for cobalt. Automotive's going to accentuate that and make it even worse. There's cobalt. I think that's it. Thanks for your attention. Great. Appreciate it.
So we have time for questions. There is the lunch afterwards, which is up in 331. Have I got that right, Max? So let's take a question, and then we'll probably have to get out of here because I think there's another class. Go ahead.
Hi, thank you for coming. I know you talked a lot about batteries. What about natural gas? Does Ford consider producing natural gas cars? I'm not sure if they are, or do you consider producing more in the future?
Yeah, so the question of whether we've considered natural gas as a fuel source, we certainly have. We've had natural gas vehicles for some time. I think it's less common here in Europe. There are a lot of biofuel vehicles that have natural gas as an alternative. Natural gas is cheap, so it's a reasonable solution. I think, though, that the challenge is the same as for fuel cell vehicles. It's storage. It's how much do we compromise the package to store sufficient natural gas. The energy content of natural gas is less than gasoline. So purely natural gas vehicles seems like a challenge because of at least for passenger cars. For commercial vehicles, it's already relatively common. The question is, do we produce those, or do we, today a lot of our vehicles are upfitted with a natural gas conversion capability, and it's always a question whether we should do that internally. I think one challenge is we don't really have the same level of gasoline costs, at least in the U.S., as you do in Europe. So there you make the switch for economic reasons. Here it's still the economics don't necessarily work. So that it's a good question, and I think. Our opinion is you can also use natural gas in other ways. So if you just look at the whole fuel cycle, you can use natural gas in other ways. So burning it directly in a vehicle isn't necessarily the obvious solution.
Thank you.
Yeah, sure.
Okay, one more.
Just a quick question. What do you think the challenges are for EVs for climates like Arizona or Texas?
Yeah, so question about
Where it's really hot.
the extreme climate. And actually, that's a good question. We do spend a significant amount of energy on the thermal management of the battery system itself. Having said that, if we do that on plug, now within reason, if we do that on plug, we can do it very efficiently. What we don't want to do is rob you of range by taking care of that. But frankly, we can probably manage at least battery temperature reasonably well. The power electronics would rather operate warmer anyway, so that's not an issue.
How about when it's cold?
Yeah,
Are there cold
and
places?
extreme cold, again, what we think about, if you will, the beauty of having a vehicle on plug is, we need to balance how much we thermally insulate and how much do we provide thermal management. But frankly, being on plug, you can do that really efficiently. You can maintaining the temperature is a lot easier than changing the temperature 30 degrees. The one other element of it is, for better or for worse, once you start driving a vehicle, once you start moving current through the battery, it warms up really quickly. That's but the bigger challenge for us is actually climate. So we think much more about microclimate in the vehicle. If you're the driver, and you want to be comfortable, we need to keep your hands warm by heating the steering wheel. We need to keep your neck warm. We need to keep your body warm. But we don't necessarily need to heat the whole cabin to 75 degrees, you know, because so we think much more about targeted climate control, because PTC heaters that we use in electric vehicles today are really inefficient. So we need heat pumps, but just like everywhere, heat pumps don't work here year round. You know, they're extreme conditions. So I think that, you know, if we can get smarter about it, and there are definitely good solutions with thermoelectric devices and other ways. And I tell you, if you have a vehicle with a heated steering wheel, you'll think you'll never want to have one without it, because in 30 seconds you've got a warm steering wheel. You know, but if you're waiting the whole time to heat the whole cabin to heat a big thermal mass, it's miserable. So, you know, I think we just have to be much more intelligent. But frankly, the good news is every time we get smarter, I mean, we introduced the Escape, one of the things we found out, we got customer complaints about things like wind noise and squeaks and rattles. The base vehicle didn't have any complaints, but the powertrain was masking all of that. So we're actually get better. The more we electrify vehicles, the more we make the driving experience better. Actually, our whole product line gets better, because we're refining everything we do. We don't have that threshold any longer. And audio systems need to be much better, right? And so I think the same is true. Every vehicle can be more efficient. We have a lot of waste heat in a vehicle, so we take for granted we have the heat. But really, when we provide cooled seats to customers, the AC load on the whole vehicle drops 20%. Because all I need to do is keep your back from sweating. You know, that's the key. Sorry, a simple answer to a difficult question.
We should take a break. With people that want to come over to Upson, please come over. I think there might be enough food for a few of us today. So. Thank you again.
Oh, thanks. Thank you.
Great.